Next thing that we're going to talk about is called properties of real numbers, and these are a set of rules that we'll use whenever we start to do some algebra a little later in the semester. So the rules that you need to make sure you're familiar with, some of them are going to seem kind of silly whenever I write them. You'll be like, well, that's kind of a dumb property, but I promise later on, whenever we do algebra, they will make more sense. So we're just going to make a list of the properties, and then I'll show you how they work. So let's start off with a set of properties that is called commutative properties. Now the word commutative is sort of a giveaway for what these properties do because it has the word commute in it. What does commute mean? Yeah, you move. Commuting's when you move. So there are two commutative properties. There's the commutative property of addition. The commutative property of addition says this: if I have two things added together, we'll call them A and B. If I do A plus B, I can switch the order of those things to be B plus A instead, and these are equal to one another. So if I said, hey, what's 2 plus 3? You would say,
3 plus 2.
Hopefully you would say 5. If I said, okay, well, what about instead of 2 plus 3, a 3 plus 2? And you would say, hey, that's also 5. That's the commutative property. There's a commutative property of multiplication as well. It also tells you that you can shuffle around the order. If I say multiply two numbers together, what's A times B? It is perfectly acceptable for you to switch those around into a different order and they will be equivalent. For example, what's 2 times 3? 6. Well, what about 3 times 2 then?
6.
It's also 6. The order in which you multiply does not matter. We only have a commutative property for addition and multiplication because in subtraction and division, it matters. If I said to you, what is 2 minus 1? You would say 1. And if I said, okay, let's switch the order, what's 1 minus 2?
Negative.
Now it's negative 1. It's not the same. Exactly right. So the order matters for subtraction and division. Okay, so let's do some real basic commutative property. Using the commutative property, how could I rewrite x plus 5?
1 plus 5?
Commutative property. X plus 5 is equal to
5 plus 6.
5 plus x. That's the commutative property. Okay. What about 3 times x? That's the commutative property of multiplication.
X times 3.
Times 3. You can do commutative property with actions also. It doesn't have to be math. Like for example, take out the trash and then put a new trash bag in the can. Are those actions commutative? Does the order matter? Take out the trash, then put a new bag in the can.
No.
Yeah, the order matters. I don't want to put in a new bag on top of the trash and then take out the trash. The order matters. But if I said I'm getting dressed in the morning, I'm going to put on my left shoe and then I'm going to put on my right shoe, is that commutative?
Yes.
Yeah, because the order doesn't matter. I can do left and right, or I can do right and left.
Have you ever tried putting your pants on after you put on your shoes?
No, I can't say I've ever tried to do that. No. Wait, what situation would you be in where you put your shoes on first and then you were like, oh dang, I forgot my pants?
The rush.
I don't think I've ever been in that much of a hurry.
Where
I couldn't just like...
I've left the house in my underwear before and got dressed while driving.
Wow, that's an upsetting visual. Thank you. Let's talk about the associative property. Associative means who you associate with. Here's what the associative property says. It has to do with the way you group numbers. Take a look at this. A plus B plus C. Now, I put part of that in parentheses. Your dear Aunt Sally, in her infinite wisdom, tells you the order to do this problem in. What does Aunt Sally say to do?
Do groups first.
She says do A plus B first because they're in parentheses. Get an answer and then add C, right? The associative property says, actually, in this case, calm down, Aunt Sally. It would be okay if we did the B plus C first and then added A. So if you're adding multiple numbers together, it doesn't matter which ones you add first. The multiplication associative property, or associative property of multiplication, says the same thing. A times B times C means multiply A and B and get an answer, then multiply by C. That is equivalent to A times the product of B and C. Associative property says order of multiplication does not matter. Okay, so here's what these... Only with addition and multiplication. In subtraction and division, the order that you do things in does matter. Aunt Sally holds dominion over subtraction and division. So under normal circumstances, if you got this problem, the first thing you would do is 4 plus 6, which is 10, and then you do 5 plus 10, which is 15. The associative property says we should get the same answer if we group the first two numbers together instead. So let's see. You said 15 when I did it like this. Let's try it here. Here we do the parentheses first. 5 plus 4 is 9, and 9 plus 6 is... Well, Lord have mercy, it's 15 again. What are the odds? I wonder if that works with multiplication. We may never know, except that it does. Let's try this. First, I would do the parentheses. -1 times 2 is? -2, and -2 times 5 is? -10. The associative property says I should get the same answer, oops, if I group the 2 and 5 together. I should still get -10. Let's try it. What's 2 times 5? 10 times -1. Oh my God in heaven. I can't believe that worked. Can't believe it. Feel all right about that?
Yep.
All right. All right, let's play the true-false game. I'm going to give you a statement, and I want you to tell me if it's true or not. It's true? Why? It's exactly the same grouping. Everything looks to... What did I change?
The 10 and the 7.
I switched the 10 and the 7. I changed the order they were in. So which property did I use? Huh? Which one?
Use the associative.
I'm pretty sure I used commutative because the 7 and 10 were still grouped together. I didn't associate them with different numbers. I just changed the order they were in. That is the commutative property. Commutative is when you change the order. Okay. Yeah, this one's true by the associative. 3 and 1 were associated together with that set of parentheses. And then over here, now 2 and 3 are associated. It's fine for me to do that because the problem was all multiplication. If the problem had subtraction or division in it, I would be out of luck. But because it's all multiplication, it's okay. Okay? We good? Let's see if you can do some simplification here. Now what simplify means is to put together your terms that are the same, put together your like terms. for example, I cannot add x and 12 together. One's a number and one's not. So I can't add those together.
So it would be 12x, right?
That would be multiplication. X times 12 would be 12x, but
Okay.
addition, I can't do it. They got to stay separate. But what can I combine in this problem?
10 and 12.
I could combine the 10 and the 12. So here's what I'm going to do. First thing is I'm going to use the commutative property to switch the order. Like that. This is commutative. And then I'm going to group the 10 and 12 together because they are both numerals. That is the associative property. And then I can go ahead and add them. 10 plus 12 is 22. So 22 plus x. Now you might look at that and think, that is so silly that you went through all that trouble of switching the order with the commutative property, then rearranging the parentheses with the associative property. Why did you not, right from the beginning, combine the 10 and the 12? If you saw that shortcut, that is awesome. You should definitely do that. Use the shortcut. But this is why that shortcut works. These properties are the building blocks that allow us to just combine the 10 and the 12 right from the beginning. So if you see that shortcut, you should do it. But that's why you're allowed to use the shortcut. We want to give credit to the shortcut where credit is due. All right, here's one of my favorite properties. I forgot what color I used. Okay. This is the hippity-hoppity distributive property. I love the distributive property. What a beautiful thing. The distributive property works like this. If you have, you'll notice first of all, this is multiplication and addition in the same problem. We're adding two things inside the parentheses, and then there's multiplication right here. This is A multiplied by B plus C. Here's what the distributive property says. I can multiply A times B plus A times C. That is the distributive property. The distributive property is awesome. I love it so much. I love your distributive property. I think you'll feel better if you all say, I love you, distributive property. Who wants to go first? So let's do the distributive property here. We know we can use the distributive property if we have a set of parentheses with a term outside of the parentheses. So let's do it. First thing you do is you take the 2 on the outside and you multiply it by the first term, which is x. What is 2 times x? 2x. There's a plus sign here. So plus 2 multiplied by y is 2y. That is the distributive property in action. The distributive property is great.
You can't simplify it anymore just because it's like tomorrow.
Right, you can't simplify it anymore because the variables are different. So we're stuck. That's the answer. Yep. Z, yes. Are you criticizing my handwriting? That's messed up. Messed up. You're probably right. -5 times -3 is
15.
positive 15 plus
10z, or -10z.
-5 times 2z, or not 2z, negative 10z.
Wouldn't that just be minus 10?
Yeah, it would be totally fine. In fact, I might even encourage you to do 15 minus 10z. That is also acceptable. You can even do the distributive property when you've got more than two things in the parentheses. Por ejemplo. Oh, it's getting real now. Hmm? 5 multiplied by x, 5x, plus,
15y.
good, 5 multiplied by 3y is 15y,
And then negative 5z.
minus, good, 5 multiplied by z, 5z. Now the only time these get a little tricky, the only time you got to be extra careful is when you get something like this. Oh, actually, it's not even the fraction that makes this tricky. This is a little tricky. And the reason it's a little tricky is because not everything after the 1/2 is in parentheses. The 10 is not in parentheses, which means the 10 is not getting multiplied by 1/2. Only the stuff in parentheses gets multiplied. So when I do the distributive property, I do 1/2 multiplied by 6x, which is 3x, plus 1/2 multiplied by 14 is 7. The 10 outside the parentheses is not multiplied by the 1/2. It's just plus 10.
So
plus
So then
3x plus
7
17.
Yes.
Yeah.
Great. 3x plus 17 when I combine the 10 and the 7. Think you could go backwards? Suppose this is what the problem looks like after I did the distributive property. What did it look like before? So what did I multiply each term by? 8. So that tells me 8 must have been the number that was outside the parentheses, right? What was inside the parentheses? So what did I multiply 8 by here? 2. And what did I multiply 8 by here? X. And what should go in between them? Plus sign. Okay, what did I multiply both things by? 7, so that's what goes outside the parentheses. What would go inside? S plus T. Believe it or not, what you just did, where you took this and went backwards to what it looked like before the distributive property, is a technique called factoring, and we spend like 90% of next semester doing that. So you're doing work from next semester. That's exciting, right?
So how much would they say simplify, or would they say factor this and this?
No. It'll say use the distributive property to simplify. We're not quite to factoring. But that's where you're getting in a short 14 to 16 weeks from now. You could be factoring full time. All right. Let me give you a couple more properties. Did you know that a plus 0 is equal to a?
Yes.
And, hold on, I'm fixing to really get crazy. 0 plus a is also equal to a. 0 is what we call an identity element. Zero is the identity element for addition. Identity element is a fancy way of saying if I add 0 to something, it does not change. There is an identity element for multiplication as well. It's not 0 though, because if I multiplied something by 0, it would change. What do you suppose the identity element is for multiplication? It's 1, because a times 1 is equal to a, and since the commutative property says order doesn't matter, 1 times a is also equal to a. 1 is the identity element. This is one of those properties I mentioned at the beginning where I said we're going to write some properties down and you're going to think to yourself, that is the dumbest property. Why do I need to know that? The addition identity is used less frequently, but still every now and then. But the multiplication identity is used all the time. It's unbelievable how often that one is used. It looks totally ridiculous. You're like, yeah, multiply it by 1 and it's the same. It's nuts how much use we get out of that. You will either be very impressed or you're just going to act very impressed so that I'm happy. The last one I want to talk about is the additive inverse and the multiplicative inverse properties. The additive inverse says if you take A and you add negative A, which is the inverse, your sum is 0. Meaning if you add something to its negative, the sum is 0. What do you suppose the multiplicative inverse is? B multiplied by 1 over B. What do you suppose that is? B times 1 over B?
B.
How about 1? That's the multiplicative inverse. Again, this one used less, but still quite a bit, and this one's used all the friggin' time. It's unbelievable. Okay, so I know I just gave you a whole bunch of properties. Let's finish up by me just giving you a list of let's say simplification, and you tell me which of the gajillion properties we talked about it is. Okay? Just shout it out, the property that it is. Very good. That is the distributive property. That is the associative property. The associative property of addition, if you're nasty. But we will accept associative.
Inverse? No.
Distributive. Oh, that's identity element.
That's the identity element of addition. Good. Adding 0 to it did not change it. I had B added, and I added 0 to it, and at the end of the day, it was still B. That's commutative. Why? What did I commute?
The 5 and the
Yeah, the 5 and the z switched places.
The identity, right? Multiplication inverse.
It's the multiplicative inverse. Good. You guys are so smart. You must have a really, really good math teacher.
Additive inverse.
That's the one. Additive inverse property. Man, you are good.
Would you ever have to simplify those? Well, I know some of the distributive are like the additive, inverse, the.
You will eventually have to simplify
Is that
some of
this
these.
semester or is it next semester?
No, you will have to simplify some of these during this semester. But for right now, I just want you to focus on learning the names of the properties.
Now it is associative.
Associative.
Right.
Associative is when the order is the same and I just change what they're grouped up with. Is that what I did?
Yeah.
Looks like the order's different. This went 6y2. This is 6-2y. Which one is it when you change the order?
Associative.
That's commutative when you change the order, but hold on. Not only did I change the order, but here the y and 2 were grouped, and here the 6 and 2 were grouped.
Commutative association.
It's commutative and associative. I'm tricky. Better look out. I'm tricky.